So in regular fallacy method, this is actually an improvement to bisection method, to which uh, instead of taking instead of taking the average of the brackets, no, you still need two guesses, no, for false position method, but in bisection method you need to take the average, no, to get the new root. However, for regular fallacy, you have an formula to find your new root. So mao ni akong kipasabot na formula. So you need to execute this formula to find your XR, and unsa ni na equation is just making a line of uh two uh two 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 brackets, no. So first is that he finds your point, no, to which the lower guess points at here, and also finds your upper, no, na creating a line out of that point, and finding, because since the linear equation you can easily find the uh the x or the root equation of the linear function. So you already create a equation that is already the root of that line. And as you can see, if we try to visualize for bracketing or for bisection method, so you're taking the half of it. So let's just say around siya dere. So your false position may have been uh, more precise or more improved to finding or more closer to the root, no. So anyways, after this we will be comparing all of this method, and per situation we need to at least investigate, no, per situation, this kind of method is weak in this kind of equation. Sometimes it will not get to the root because maybe sometimes you are just playing, so nag back and forth ang imuhang pag-find sa root, no. So like just like that. So same equation, no, ay same problem, no, katong parachutist na problem. So however, dili na nato i-take ang average, we need to solve for the new root based on this one. So x sub r is equals to x sub u minus f of x sub u multiplied by the difference between x sub l minus x sub u all over the difference of f of x sub l and f of x sub u. Okay, so yeah, since our first initial guess in bisection method was 12 and 16, so ato lang sa is. So yeah, so 12, no, we have of the value of f sub l, and for upper, which is 16, we have the value of f of x sub u. Then for x sub r, using that equation, we have now 14.9113. So in the first iteration also, pag divide na to, that was 15. And in false position method, you can see that it is 14.9, which is much closer to the root that we are trying to get. So you could say that it is more reliable to bisection method. And same situation, no, same deciding factor, to wherein unsa imong i-replace, it should be the lower and the upper. So same ra siya og deciding factor for bisection and false position method. The difference is that how you will compute for the x sub r. So for second iteration purposes, that is, yeah. So until he get to 14.7. So as you can see, na siya yung mga decimal values, no? Compared to bisection method, it started in integer until it gives you a decimal value. Okay, so the Rahutov for bracketing method. So let's try to solve this one in Excel. Okay. So I think I have already put uh, the problem here in Excel. Okay. Uh, okay. So what we know in the bisection method is you have at least uh, two guesses, no? Or same with irregular falsy, you have two two guesses. So you have the upper guess. Let's just zoom this one. Okay. So that you can see. So upper guess. Okay. You have the lower guess here at the next right to the upper guess. So let's just say that, yeah, your upper guess is 16 and your lower guess is 12. So yeah, so the given equation, let's just say your governing equations now. Your governing equation in this situation is that one. So let's just insert that equation. Kanin lang natin ibutang. Itong i-crop. So, para fair, no? So, mga ipagkog proper solutions po ninyo because I presented to you well also in giving you in explaining you how we should do the solution. So this is your governing equation. So kihatag na niya. Then you equate this to 0. So para makuha nimo ang C, but in sa analytical method na siya. So in using, let's say this is the given already. Let's just say siya. Then what is required in the problem is actually finding your C, no? So solution, you will at least describe here finding the value of C using bisection method. So in finding the bisection method, the root using, in finding the value of X using the bisection method, you have at least an iteration equation. So let's just say you insert an equation. So your iteration equation for this particular situation is based on the method that we learn from the bisection method itself. So our iteration equation, no? Let's just say that, just say your x sub r here. Let's use both. No, let's do it again. So insert equation. So drag this one. So let's just say since you are trying to repeat the calculation, so that is why you need to declare the iteration equation. So your so yeah, so both, no, let's just say your C, since you are using C variable R, and you are iterating, no, so taking the new value of your C, so that should be I plus 1. For a start, your I should be equal to 0. So that is equal to, since bisection method is just taking the average, so that should be, yeah, just the average. So starting with the lower guess. So that should be C, L, and I, no? Plus, yeah. So that is C, U, and I. So notice that I am very particular with the upper script and the lower script. It's just how you describe, how you exert, or how you manage how you manage the iteration, no, when you presented the table. So since you already have the iteration equation in this matter, so you have to see, then you have to put here that you need to apply also the deciding factor declared in the bisection method. So there. Okay. So now you could create now the graph. So create the graph. Create the table pala. So first is iteration. Let's just say you started at 0, no? And first is you need to find you need to have lower and upper guess. So C na lower guess and C na upper guess. And C that is calculated, which is the root. And yeah, you need to find the F of CL, F of CU, and F of CR. So, delete na lang kayo na nako. Strictohon ang description sa baba. Pagdaling Osborne as CL, CU, and CR. So, yeah. So, we will put here an error, no? Just to see how much error did you get in every iteration. So, first in the 0 iteration, so initial situation here. So, we have 12 and 16. And again, we are taking the average. So, you're just taking the sum of your upper and lower guess and dividing it to 2. Now you need to evaluate, no, these three values, no, to the governing equation, which is that one. So that is 9.8. So if you're not familiar with how you write an equation to Excel, then yeah, maybe take consider it, no, study how you will write equation properly in Excel. So, kalaning ospunpod kay sayop ang spelling. Okay. So, balikon na to. So, that is, yeah, close parenthesis. So, that is 9.8 times 68.1 divided by your C. So multiplied it by, yeah, that one. So 1 minus, I think I will create another parenthesis. So exponential, so that is exp. And that would be negative of, yeah, negative of C, or this one, 12, uh, times 60, no, divide this, divide, where's the divide, 68.1 times 10, close parenthesis, then close parenthesis again, then close parenthesis minus 40. So that should be 6.066. So sakto no, katong from the previous solution it was 6. Then you just have to drag this one so that it will evaluate for 16 and 14. So yeah, ano siya. So kani. So you can now evaluate now. So error, di pa ta ka-calculate. So 1. So for the first iteration here is we need to decide to whether you need to replace for the CL and the CU. So how could we do it? How could we do it? So there is what you call if statement in Excel. So that is if you're given with logical test here. So if 12, yeah, if this one sa 12 will be multiplied with this one sa CR. So I think I will just gonna taking the parenthesis of that one. If that is lesser than 0, then you should replace the upper, no? So if that is true, that will be replace the upper. So if it's not, it should be replacing the lower. I don't know. I'm sorry. If it is lesser than, if it is lesser than 0, then you should be, I think atong balikon eh. Yeah, you should be replacing the the lower, no, the upper one. So meaning you will take the lower value as is. So you will just put it here, no? Okay, true man ang situation for that matter, or else replace it with this one, no? So, so that is, so, should be lesser with this one, should be. So if the logical test is true, okay, true man ni siya na situation, then it should be not 14. Let's just try this one. So if multiplying this one with this one, if it is lesser than 0, then you should be replacing your upper with this one. If false, then just this one. Yeah. 16. Na sakto dayo, sakto day. So, yeah, so you will just drag this one. So you have for 15 now. So same no. 15 ang katong ikaduha nato na ki-solve for the root. So ato lang pud ning i-drag no, because it will be just calculating for the new ones, the new sets of values, and you could now solve for the error. And for this time we will be, and for this situation we will be just using relative error. So that would be yeah, for just for CR no, uh the difference of this. So you will think so absolute value of the difference of this one and this one, then divided by the new one, the new value that you solve, which is this one. Then yeah, make it a percentage, so that is 7 or 6.67. So since you establish the formula for the bisection method, now you will just have to drag all parts of it. So ako na siyang i-drag dire siya. So limitless na ang pag-drag, di ba? So as you can see that your 14 at first is becomes 15, and it becomes 4.5, and it becomes 4.75, it becomes 4.8 something, and 4.8, then ibalik na po siya sa 7, no? So in ana ang situation for bisection, usually mag-ambak-ambak. So okay, so let's just say the acceptable percentage should be lesser than 10. So let's just keep it continue. Yeah, so lesser than 10, then we have this one. So 4.77. So let's delete this one. Then have it as your root. So mani imuhang na solve na root out from the bisection method. You could use calculator no in solving the root also to double check the value, no? So that is bisection method. So how about if we try to solve it in regular falsy? So dili nato ibutang sa kilid. So finding C, the value of C using false position method. Then you will now have new iteration equation. So mag-base ta sa katong ilang ki-declare na formula, which was so insert tag equations here. That should be siya, no? So pwede ra sad na to i-kopya ni. Ito lang Osmon. So sa regular falsy or false position method, you have so that is CU. So I will copy this one para mas madali. CU minus F of CU. So that is Yeah. F of CU, and then taking the difference between the lower and the upper, so that is minus nga, dayon all over, wala ni siyang kopyahan para mas madali. Happen. So that is eh, that is L. So yeah, wala na siya, sakto na siya. Then we apply also for the values of for the deciding factor of the bisection method, then use this kind as use the governing equation in finding f of CL, f of CU, and so on and so forth. So I think I will be just copying this one, no? Para madali ta. Then yeah, our name is as false position method. So think ako lang pod ning i-delete, no? Delete. Control C. What happened? I'm sorry. So that is false position method. So na, and then delete sa ni nato. Okay. So ang ma-change sa dere is how you will compute with the CR. So that should be CU, which is this one. CU minus parenthesis. So so that is CU. Kani siya. CU minus parenthesis, then parenthesis pa yun, that is FCU times the difference between CL and CU, and close parenthesis divided by open parenthesis FCL minus FCU, close parenthesis, then close parenthesis. So that should be it. So ano, so same, no, sakto, no, 4.9113 as you remember. So that should be that, no. So deciding factor is the same. So ang 16 ma-replace, then you will just drag it. Let's just see. So as you can see, it reaches 4.7817 at the second iteration. So ako na lang po ning i-delete. Okay, all we need is lesser than 10% relative error man. Delete. So you compare, yeah, I think the regular falsy is much more better than the bisection method, because you just need, at least three or two iterations uh to solve for the value of root, which is very acceptable compared to the bisection method, that it reaches na nag-ambak-ambak pa gid siya, no, up sa around 4.7, but still it does not gives you the best relative error there. So it's safer to say that, yeah, false position method in this type of equation is much more better. Yeah. And that's it. So hope you learn and how to solve, no, for the rest of equation using the methods for bucketing method. The next one we will be talking about is for how do you solve roots of equation using open method, in which you will be just um, guessing only one. So in bracketing, you need to have at least two guess, no, the upper and the lower. Wherein in open method, you have to at least one initial value, then it will automatically run. Okay, okay, that's it. Thank you.